Hello everyone, I'm Miss LaPointe and I'm making a video on how to solve for a missing addend. When we say addend, we mean one of our smaller parts in our equation that adds up to our whole number or our sum. One strategy we can use to solve for the missing addend is to draw a picture. I'll rewrite the equation that was already on the board. So we had 26, one of our addends, plus some number, our second addend, our second smaller number that we have to solve for, equals 51. If we were to draw a picture, we might do something like this. We're going to start with 26, so I'm going to draw my 26 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Now that we have our 26 dots, our first addend, we want to know 26 plus how many other dots will give you 51. One way you can do that is to continue counting on from 26 and add your dots. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. Now, to solve for our missing addend, we have to count our pink dots, the amount of dots that we added to 26 to give us 51. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Our missing addend would be equal to 25. Now, another way we could solve for a missing addend is to use a number line. When using a number line, it's important to start with your first addend. So I'm going to mark 26 on my number line first. And it's always easy to count by 10, so we know we need to go from 26 and work our way all the way to get to 51. I know that it's easy to count by 10, so I'm just going to count by 10s first. Plus 10. 26 plus 10 equals 36. Not quite 51. I'm going to add another 10. 36 plus 10 equals 46. Still not quite 51. Now, maybe I want to add another 10 plus 10. But, oops, that equals 56, and that's too much. So what I'm going to do now is just get myself up to the 10. So in our tens place here for our whole number, our sum of our addition equation, we have 51. We want to work our way up to 51. Let's get from 46 to 50. I would have to add 4. 6 plus 4 makes a 10. Now we have 50. To get from 50 to 51, we would just have to add 1. And now we're at 51. In order to fill in this missing addend, we have to count how many we added, how many jumps we made from our original addend. So here, 26 plus, 10, 20, 4, and 1 would be 25. There's our missing addend. equals 51. Now another way you could look at this, another strategy you could use is using base 10 blocks. So breaking up the numbers into place value, and your students should be familiar with this. So our tens will look like this, as 10 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, make up a 10 block. And our ones will just look like these dots that we see here. So if we break up this number 26, we have 2 tens and 6 ones. I'll start by drawing our base tens now. 2 tens, 6 ones. Plus some number is going to give us, and again, we're just going to use our base tens. 5 tens, 1, 2, 3, 4, 5, 1, 1. Now using base tens, you can kind of visually look at the picture and you know, well, we have 2 tens. Some students might say we need 3 extra tens. If this were true and you added 26 plus 3 tens, 26, 36, 46, 56, that would be more than our sum. So we know 3 tens would be too much. What you can do is take away 1 10 and then count on with ones. So from 26, now you have 36, 46, 47, 48, 49, 50, 51. So 26 plus 10, 20, 1, 2, 3, 4, 5 equals 51. That's how you would use the base 10 strategy to solve for a missing addend. Lastly, we can use our fact family strategy. If you don't like using an addition equation, you can always flip your addition equations into a subtraction equation. Fact families have 2 addends and 1 bigger number. Here we can look at it like this, almost like a house. We have 2 smaller numbers and then we have our whole, or our sum. Now we didn't know this part. We didn't know our second addend, so I'll put a question mark here. But since we do know what it is, I'll fill it in. Now what a fact family does is it shows us how we can break up an addition problem to make a subtraction problem or vice versa. So to start off, I'll just finish off our equation we see here. 26 plus 25 are 2 addends, our 2 smaller parts, equals our sum or our whole, 51. Now, using the commutative property, you can flip these 2 numbers and it would give you the same sum. So 26 plus 25 equals 51. 25 plus 26 also equals 51. Now, if we were to do our subtraction problems always look a little different than our addition problems because our sum, or our bigger number, always comes first. We can't take a smaller number and subtract a bigger number from it. So I'm going to take my sum, 51, and then you're just going to subtract one of your parts, or your addends, your smaller numbers. Minus 26 equals 25. 51 minus 25 then must equal 26. So now, if your student doesn't like using addition and they prefer subtraction, they can change their problem around. So 26 plus some number can turn into 51 minus 26 equals some number. Maybe your student really likes using the stack and subtract strategy. From here, your student can just subtract 51 minus 26. If we look in the ones place, you can't take 6 away from 1, so we have to regroup. We're going to make this 5 tens of 4 tens, and we're just going to borrow tens and put it over in the ones place. So now we have 10 plus 1 is 11. Now we can subtract in our ones. 11 minus 6 is 5, and 4 minus 2 is 25. Our missing addend for this problem would be 25.